G'day guys. I've been playing around with cables, making up my own detector cables, and I have come to a conclusion that you do not need Litz wire to make a good cable. And apart from that, I've on the bench at the moment, you can see on the oscilloscope there, that is the transmit cable in some double D coil cable out of a commander coil. And have a look at the frequency generator there, 1.272 megahertz or 1272 kilohertz, however you want to say it. And you can have a look at the waveform there. It's got a bit of a kick to it. That's due to cable capacitance. But the main thing you want to look at when you're checking your cables, or any type of cable, and there goes something on the floor. Like I say, it's pretty crowded here at the moment. There's things everywhere. But yeah, I'm just testing out the double D. That's double D cable there. I'm on the transmit side of it. And I can tell you something really funny about that in a minute. This is a coil I had laying around. And I'm not joking. From day one, the transmit cable and the receive cable have been transposed in the plug. I'm not joking. Well, at the moment, I've got that on the transmit side, and that's what we're getting, just over a megahertz. But I'll tell you one thing I noticed on the receive side, square waves are a lot cleaner. So what I've been actually doing is having a look at, well, that's sort of a square wave. Well, sort of. But the main part you want to look at when you look at cables, and at whatever frequency you want to look at, well, in my case, I'm pushing it as high as I can, and still having a resemblance of a square wave. You don't want to check sine waves, because I'm doing pulse induction detectors. They don't work on sine waves. They work on very sharp, snappy turn-offs, and you want to get the received signal without any time decay. Well, you're going to have it, but you don't want it due to your cable and your coils, basically. If you have a look here, I'm doing this by hand at the moment. I'll probably end up dropping the phone. Yeah, but where I've got those cursors there, you can see on the bottom there, and I'll just go to the top of that capacitance blip, and overall that's a delay of 72.2 nanoseconds before it straightens itself up. I mean, it's going to detect small targets within that thing. I don't think any target really decays at 72 nanoseconds. It would be a few atoms of gold, anything like that. But what I'm doing, just checking how good the cables are and just measuring their frequency response, capacitance, losses, their 3 dB points in relation to frequency. Like, we have a look at this one here in the transmit. I'll just wind the frequency up, and we'll just go, it's going to go complete. It's not going to be a square wave anymore. Cable capacitance is going to turn that into something of a sine wave or something. But we'll go down to the 3 dB point. There it goes. Look how haywire that is. So that's why you can't run data through this cable at 6 megahertz. You're not going to be able to do it. You can run analog through it, but then here we go. We're going to go to the crash test, and there's our 3 dB point, which is half power, and you can run this cable up to 16.52 megahertz to its 3 dB point, but we've lost our square waves. If you had transitions happening at that, there's no recovery of information. That's just doomed. So we'll drop the frequency down again, and it's starting to square up a bit. There we go. We'll get a, I don't even know if we can make a proper square wave. I'll just dump it down there. Have a look at this. There you go. Have a look at the, there's ringing. You can see ringing on the waveform. And yeah, it's got that capacitor blip on it. Yeah, nothing I can do. I think I can go all the way down um, frequency wise and it'll still be there. I'll drop this down a little bit more. I'm pretty high up. But where are we? 15 kilohertz or so. And we've got little fine, little, little things shooting upwards on the leading edge. Probably can't see them, but they're there. There we go. So that's what you want. You want nice square waves. We're down to 13 kilohertz now. And you push it up, and the other way of checking it as well is fix that up a bit. I mean, that'll work. I mean, that's very, very fast initial blippy transition there on the leading and trailing edges. I wouldn't worry about it too much. And we can also we can go into putting out some sawtooth triangular waveforms and yeah, just see how quickly they lose shape. Square waves are better to do it with, but we'll just crank this up there. You see, we're at 15, well, 1.5 megahertz, not 1500 kilohertz. I'll say megahertz because that's what we're into. And if you look at the waveform, see that you can see that the sharp top and bottoms are starting to round off, and that's we're putting around about 3 megahertz through that cable, and now we're starting to see a power drop. There we go. We're dropping down, and at the 3 dB point, we can only get up to 12.94 megahertz. So it's all to do with transition speeds. Basically, what you want is the lowest capacitance possible in your cables. You do not want high capacitance because it will slow down transitions and you'll lose small targets. So we'll go back to sine, then square. You know, that's pretty sad. That's at 5 megahertz. Look at that. That won't cut the mustard. But metal detectors are very, within reason, low frequency beasts. They're not running at megahertz. They're all running at tens of kilohertz. So yeah, they do get a bit ropey, but there's a lot of difference between the cables I found. This double D cable too is actually shorter than a normal one because it had a break in it and it's lost about 30% of its length. So with all the you know, capacitance measurements and so forth, I have to add 30% to it. But they are high capacitance cables. They're so skinny. But what got me is that the receive cable, it's got a lot less strands than the transmit one. I don't even know if you can actually see on this, but if I unclip all this, I'll try and do it one-handed. If you hold this up, I don't know if you can actually see, but the one on the left-hand side is the receive, and the one on the right-hand side, obviously, is the transmit. Transmit is a lot thicker. It's got more strands in the middle, and the receive one's very, very few strands. But the receive one, if it wasn't for the resistive losses, would make a better cable than that big, thick transmit one. So obviously they made it big and thick to handle the power from the detector on the transmit into the coil, and the receive is basically very light duty. There's no real current involved, so you can make it thinner. But then again, by making it thinner, you're increasing the resistance overall. And yeah, fudge factors, there's probably some signal loss, but you know, maybe nothing to be worried about. That's why I made up some cables which are sitting here, which is I've gone to using a transmission line techniques, and mainly I'm doing that to get rid of interference getting in on the cable into the detector. I actually I rolled my own cables, and that's why we got different heatsink. Yes, heatsink, heat shrink, try again, because I ran out of the black. I always do everything in black, but I had to go and get some 20-year-old white. I don't know how good it is. I don't know, grabbed all right. But yeah, I've got some different cables here. I mean, also testing mono cable, wherever it is, somewhere. All these cables in front of me. Yeah, that's your mono cable. If you have a look at that, it's got a big polyethylene middle insulator. That's that white part, fairly thick Litz wire construction. For the middle and the outer, it's all insulated strands. Whatever there is, I did count it once upon a time, many years ago, but not lately. And what I have discovered that, well, it's not really a discovery because I've done it ages ago. You don't need Litz wire in these things. Everyone says, oh, you got to use Litz wire. Actually, no, you don't. It depends on certain factors. My cable's faster than the mono cable there, and I'm not using Litz wire. There's no Litz construction whatsoever in it. And yeah, it's fully shielded. Well, Litz wire itself is about 90% shielded. Did you know that? It's average, and yeah, my one's 100% shielded. So that's that one there. So that works really well. I could hook it up, but I'm one-handed. It's very difficult. I've already hooked it up and tested it. So, and it's got lower capacitance than the same length of mono cable. The mono cable for 1.5 meters was 142 picofarads over the length, and my transmission line cable was 122. So I can make it a lot less as well. Actually, I did make up some experimental one. There's one down there on the ground, I think, somewhere. Where are you? Oh, it's over there on the end of that. This one here, that thing there, that is 70 picofarads over 1.5 meters. But I'm not going to go into that one because that's special. So very special indeed. You can make some very, very fast, really good coil cables if you do things a particular way. And it's funny, I can't work out why no one's done it. I can do it, and no one else has. And it doesn't react with, well, basically, if you wiggle the coil cable on some of these things, it makes noise. And the ones I did, they don't. It's basically a completely balanced system as such. But there's some tricks to the trade in there, which I'm not going to divulge. And it works really, really well indeed, and totally not susceptible to interference. And if you want to check your cables, if you've got an oscilloscope or even on a detector, get something like this. Get this little DC brush motor thing and fire it up. You know, it's going to make a horrible racket, of course, and put that near your cable to see if you can induce any EMF in through the side of the cable into your detector. It'll go whop 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 if it gets interference. You might be able to see it on your oscilloscope if you have it cranked up enough, put in AC coupling, and just try and have a look and see if you can see anything. Better off on a detector because that's what you're using. Use the detector to be a noise receiver. And while you do that, put on a double D coil or some type of coil with antiphase, or or double D in cancel mode. So if you've got one of these type of detectors, like that thing sitting in front there, is that my fingers in front? Yes, it is. That's what happens. Yeah, when I'm doing things, holding this by hand. So yeah, I'm going to make up some really good coils, guys. Actually, it's been a bit of an issue making coils because in the past people don't want me making coils, right? It's a big long story, but at the end of the day, I am my own man. I am my own boss. And I think that I should ignore other people's wishes and trying to stop me doing things and just do it. So I will be building up some ripper coils, and I mean really fast, low loss coils. Um, I have done it many times. There's people out there in the professional part of the detecting industry who've seen my coils. They won't say anything about them, I know that, but they were very impressed. This is going back some years ago. And it's sort of this thing that I wasn't going to make coils, but I really thought about it. I could commercially make coils. I mean, we do make commercial coils. We make the big coils. We make those big um, drag type coils. And actually, Dave's in the middle of making up some fiberglass framework to make very light, massive coils that you can actually swing. So there'll be something like that popping out soon, and they won't be you know, delicate and fragile type things. These will be all right. You can bang them around a bit. So that's his project at the moment, and I'm just doing lots and lots of experiments because I want to get away from using particular type of cable. And this is another thing, guys. Because I can get lower capacitance in the coil cable I make, I can make it any length. We'll also be able to make, rather than have extension leads for coils to put behind quad bikes, we can now have just one great whopping long coil cable. And if you want it 15 meters long, I can make it 15 meters long for you, so you get away from your quad bike. But you've got to get the capacitance out of the cable, and the way I do it is probably the only sane way of doing it without copping interference. Okay, it's basically, if you know how things work in the electronics world and that, we'll call it. How about we'll call it differential cable? Okay, you might like that one. Have a look up um, differential amplifiers and anything differential, and you'll see that it cancels interference just in its design. But you can't just do it for a detector without doing something else. And actually, it's two things you've got to do. Otherwise, it'll be really quite noisy to a degree. Not really, but yeah, it could. High frequency noise, yes, not low frequency. But we take care of that as well. We got ways of shielding that, but I'll call it. Uh, it's hard. If I say it, it'll give the game away. I'll tell you, I'll bloody shoot myself in the foot, and everyone will be, "Oh, you must be doing that." You can guess it for the time being, because I tell you what, anything you come up with that is really innovative, um, the commercial interests out there will just steal it. They'll just take it. You know, like flight modifications. When I was told that. Um, a fellow told someone that I taught him everything he knew. But he'd spoken to him for about half an hour on the phone, so that was must have been a lot of download, half an hour. But there's a lot of strange stuff out there at the moment, a lot of weird stuff. We'll call it weird stuff, strange stuff, typical human nature stuff. We'll call it that. There you go. Some real funny stuff. That is going on, but I'm not going to entertain that too much because I don't need to get involved. There's enough happening at the moment. Yeah, so anyway, this is where we are with our coil stuff. And notice how I was in the middle of doing a detector upgrade and I got sidetracked by coils and coil cable. It's only because I had some stuff come in and I was absolutely busting to get my hands on it. And yeah, so I made up some coil cables and tried it out. But for very, 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 very super fast, high speed cable, yeah, we can make it. We'll make it better than what's out there. I'll say that we'll make it that what's currently used on detectors what we make is better than what's out there because I've tested it. It's got higher capacitance, which means it's slower, and little signals don't high frequency decay get squashed out a little bit by the capacitance. So you can make a more sensitive coil setup if you use a particular specialized cable. And the other thing too is that I'm going to go back and build some. Actually, I'm going to build some really good coils, but the coils I'm going to build is based on based on stuff I've known for I don't know 25 years or so, and new stuff I've come up with and known. Like there's some really good stuff I'm doing. How about you seen inside? I think I did some stuff on X coils or some of those coils out there for particular detectors, and they got big ferrites inside the coils. How about if I said that I have a way of completely negating the use of those big ferrites, and you don't need anything like that whatsoever? Okay, and the coil will be more efficient. It will be less reactive. It'll be more sensitive, right? So, this is all the stuff I have inside my head, and I don't usually, I don't go parading it around because you'll see commercial interests jump all over it and just hog it like it's theirs. And sorry, nah, not gonna divulge. But I'm going to show you my new coils. I'm going to make them up. Um, I'm going to make a 5x10 elliptical. The reason being is because down there is a commander coil housing that I'm going to use. So when I build this up using my special techniques, I will, it's going to be a mono, not making it a double D, but I will put my coil up against any coil of the same size, and I'll bet 10 grand that my coil will beat anything out there. I have no problem in saying that. I can beat the pants off everyone else's coils. Easy as, not even hard. Because, even though all the coils, commercial coils work, they work, right? I mean, you can go and drive down the road in a Fiat 500. That works. Or you can have a Lamborghini. That works also. But when it comes to coils, I'll be making Lamborghinis, and everyone else can run around with their Fiat 500s or their HR Holdens. But I'm really going to say this because I've been pulling my head in through external influences for too long, and I really need to tell them to pee off, get out of my face, and stop trying to shut things down. Because I'm really over it. I'm really over it. There's going to be a lot of stuff coming out soon, and you're all going to be surprised. Some of the stuff coming out, you're going to be surprised. But, hey, there's only me and Dave doing this. We might have to start employing people because it's just too much. I mean, you're too busy. It might sound weird, and you may understand this and you may not. But I'm so busy working that I can't do what I want to do, right? It might sound stupid, but I don't want to sit down all day locked into and all night locked into um, modifying detectors where I should teach someone else to do it. Then I can get onto my designs and innovation and and make new products. What happens is you get caught doing the same things, and because it's just endless. It's absolutely endless doing modifications. It's bonkers, and I can't get onto my other projects. I mean, there's half-made new detectors kicking around I can't get onto. Um, there's all sorts of stuff. There's all DSP projects I'm working on to get the noise out of detectors, so you don't have noise. I managed to get one done, which is I'm just waiting on the boards to roll up at the moment, which is going to be an absolute game changer, right? I'll give you an idea. You'll love this. Guys who've been around a while might know this. Finders. I'll say finders. Um, Ken Roberts, who had finders back in the 80s, 90s. It's not there anymore. It's in Denali. Worked on a thing called the Superfix. The Superfix was very, very complicated. Basically, it only beeped on gold and ignored everything else. Well, that's what it was meant to do. Okay. I remember looking at the board when one of the tech guys was building it, and I said, "Jesus Christ!" Yeah, I couldn't believe what I was looking at. But anyway, um, I'm not going down that path. I'm going down a different way, right? And this is going to, I'll tell you what, for people who've got really bad hearing and can't, uh, I'm going to let the cat out of the bag again, aren't I? Put it this way, some people are completely tone deaf or have a limited ability to hear changes in tone. So this is going to cure that totally. And anyone who has a hard time using a detector is going to greatly benefit from this in a particular way. But I've got about 4 projects I'm doing on this basis, right? We'll call it, well, there's ones that are based on haptic feedback techniques, okay? There's ones that are done on, like I even came up with a heads-up display for modified glasses you can wear. You don't even need to look at a screen. You can have a heads-up display like a fighter jet if you really wanted to. But I don't know if that might be just too overkill. But you can do this sort of stuff, and I have been sort of tentatively mucking around with it. Now you're going to see people come out with bloody visors with heads-up display on it for metal detectors. I guarantee it. But it's a project I didn't want to pursue because it's too out there and too away of the fairies. But it can be done. But there's better, more grassroots type things to make. Anyway, I'll get on to it. So you're going to see some stuff come out. You're going to see it. I'm going to do it. And I'll tell you what, no one's going to stop me doing it either. People have tried in the past, but they're not going to stop me. There's a hell of a lot of stuff I'm going to start bringing out. There's reasons why they tried to, and but hey, I'm my own person. I'm my own boss. I'll do what I think fit and not listen to any other comments on it from now on. Even me saying that, it's probably going to get back to people and cause absolute mayhem, right? But I don't care. It's my IP, my ideas, and I will be doing it. So who's going to benefit? Detectorists, people looking for gold. You're going to benefit. So I think I better get stuck into it. Anyway, that's my, you can see, like I said, I was building up cables and stuff, proved my point, checked it out, totally anti-interference, very, very quiet, basically faster cables, quieter, a bit of signal processing. I mean proper signal processing, not, the lame stuff that is out there. I mean, really proper signal processing. But not going to go too far into that, else I'll say too much. And yeah, some really good stuff coming out. There is stuff coming out which is really good. Wait till I get my boards in, and I'll quickly build up some things. I can't. You got to understand, guys. I've been caught with this before. I've built up stuff before, and I absolutely drip feeded, or drip feeded. I saw Charlie stick a head through the door, and I thought of food, and I said feeded. Um, Drip fed I drip fed production. Big, big mistake. It just gives everyone who has production facilities the heads up to absolutely run over the top of you. And that's exactly what happened. So no more, I can't drip feed. I've got to actually go and put hard money into all this stuff and build up stock and just go bang, cop that. Get this distribution lined up around the place and not drip feed it. I can't drip feed anymore. It's got to just be bang. And that's why I say I've probably got to start employing people. Not that's my favourite thing to do, but yeah, I'm looking for people with particular talents at the moment too. So if anyone's around Ballarat who um, can how do I say really top notch in digital engineering, and I'm talking not programming as such, but I'm talking algorithms for DSP protocols and stuff like that. Let me know, because might be a couple of jobs for people with that expertise. There might be jobs for a lot of people. Depends how fast and how hard I push this. But yeah, we're gonna conquer the world, aren't we? I don't know. I'll suffer burnout doing it, but I'll get there in the end. I will. Anyway, um, yeah, you're going to see a lot more stuff. I'm not gonna hold back anymore. It's all coming out. Catches.